All right, in this video, I'm going to be doing a little bit more talking about evaluating trig functions using the unit circle, and then we're also going to talk about evaluating trig functions by drawing triangles in quadrants. So I'm going to title the notes Evaluating Trig Functions using quadrants, because that's kind of like the primary new thing we're going to look at. So first, we're going to say that you were trying to evaluate a problem. I'm going to just write down a couple examples. So let's say we have tangent of 13 pi over 6. Well, that's not as straightforward as what we have been doing because that's not on the unit circle. So this angle is actually coterminal with an angle that is on the unit circle. So that means it's coterminal. I can go ahead and I can take that angle and find another angle that's coterminal with it. If you look at the fraction, 13 over 6 is a fraction that's bigger than 2. So this is a little bit bigger than the unit circle. So if I take 13 over 6 and I subtract off 2 pi, then that would be like I'm subtracting off 12 pi over 6. So I'm going to go ahead and do the math by hand so you guys can see it. And just if it's calculator active, then use a calculator. And if it's not calculator active, then you can do it by hand. So 12/6 has a common denominator. That's why I wrote it that way. But 12 divided by 6 is 2. So this is me subtracting off 2 pi. I end up getting 1 pi over 6. So instead of evaluating tan of 13 pi over 6, I'm going to go ahead and evaluate tan of 1 pi over 6 because that is a value that is on my unit circle. So if I go ahead and look at my unit circle, tan of pi 6 is 1/2 divided by square root of 3. So I'm going to go ahead and write, I know the 2's are going to cancel, so I know that this is 1 over the square root of 3. And we are not supposed to have square root of 3 in the denominator, so I'm going to go ahead and rationalize that fraction and multiply by square root of 3 over square root of 3. And so I get tan of pi over 6 equals square root of 3 over 3. And if you want to double check that on a calculator, you can. So in the mode I have radians, I can do tan of 13 pi divided by 6. So I'm going back to my original problem to make sure I got the right answer. And then square root of 3 divided by 3 is the same decimal. So I know I got it right. Okay, we'll go ahead and try another one. So for this one, I'm going to do sine of 17 pi fourths. So sometimes you'll see them put parentheses around it, sometimes you won't. It doesn't matter either way, you're still doing the same thing. So 17 pi fourths is definitely larger. 17 fourths is larger than 2. So if I say that I have 17 pi over 4, then I would be subtracting off 2 pi, which means I'm doing 17 pi over 4 subtract off 8 over 4. And if I do 17 subtract off 8 pi over 4, 17 minus 8 is 9 pi over 4. And that is still too large. And so I'm going to have to do that again. 9 pi over 4 subtract 8 pi over 4 is just pi over 4. All right, so now I can look at my unit circle. Sine of pi fourths is what I'm actually evaluating because sine of pi fourths is coterminal with 17 pi fourths. And if I look at pi fourths, sine is going to be root 2 over 2. And then we'll go ahead and do one last example like that. So here we're going to do secant of negative 7 pi over 6. Secant of negative 7 pi over 6. So with this problem, you have two different options. If you are comfortable with negatives, then you can go ahead and leave it as a negative angle and look at your unit circle and just say that if I was going in the positive direction, I would end up over here at positive 7 pi 6. So if I'm going in the negative direction, I'm going to be like on the mirror image of that. I'm going to end up at 5 pi 6. So you could do it that way if you're comfortable with the negatives. If you're not, then we're going to go ahead and take negative 7 pi over 6. We're going to add 2 pi to that. So negative 7 pi over 6 plus 12 pi over 6 gives me 5 pi over 6. So either way of thinking about it will get you to the same answer. So secant of 5 pi over 6 means that I'm looking at 5 pi over 6 on my unit circle. I'm taking the x-coordinate and I'm flipping it. So that's going to be negative 2 over square root of 3. And I do need to rationalize this fraction, so I'm going to multiply by square root of 3 over square root of 3. And that gives me negative 2 square root 3 over 3. So just a reminder, if we wanted to type this into our calculator, I don't have a secant button, so I'm going to do 1 divided by cos of 5 pi 6. Actually, I'll go ahead and type in the original, negative 7 pi 6. And then if I do negative 2 square root 3 divided by 3, I get the same decimal, so I know I did it right. Okay, so I'm going to go ahead and say, to summarize what we did, if the angle is not between 0 and 2 pi, then add or subtract 2 pi until it is. So basically find if your angle is not on the unit circle, then find a coterminal angle that is on the unit circle. And we find that coterminal angle by adding or subtracting 2 pi. Okay, now we're going to go ahead and switch into problems where we're going to have to draw triangles to do them. So first we have to draw the different quadrants. So we have quadrant 1, quadrant 2, quadrant 3, quadrant 4. And then I want to think about what points are positive and negative, which coordinates, the x or the y. So in the first quadrant, we have positive for x, positive for y. In the second quadrant, negative for x, positive for y. In the third quadrant, negative for x, negative for y. And in the fourth quadrant, we have positive for x, negative for y. So if we look at the first quadrant, that means that sine is positive and cosecant is positive. Cosine is positive and secant is positive. And then y divided by x would mean that tan is positive and cotangent is positive. So if we look in the first quadrant, all 6 trig functions are positive. All right. If we look in quadrant 2, sine is going to be positive and cosecant is going to be positive, but cosine and secant are going to be negative. And y divided by x means that tan and cotangent are also negative. So the only ones that are positive in quadrant 2, I'm just going to say sine and cosecant. So just those two. Quadrant 3, we have that sine and cosecant are negative, cos and secant are negative, but when we divide these two, we can see that tan and cotangent will be positive. And then in quadrant 4, sine and cosecant are negative, but cos and secant will be positive. And then of course when we divide those, we're going to find that tan and cotangent are negative as well. So here's how I remember this. I say all students talk constantly. All students, so S for sine, talk constantly. So all, sine, tangent, cosine. And then you can remember what is positive where. Okay, So now we're going to go ahead and we're going to use that to go through some example problems so you guys can see how that might be actually utilized, I guess, to solve for trig. Okay, so here is our first example. All of the instructions for this are going to be find what quadrant theta lies in. Okay, find what quadrant theta lies in. So here's our first example. Sine of theta is less than 0, and cos of theta is greater than 0. So which quadrant, which of the four, could our angle be in? So first, I'm going to draw the little picture. All students talk constantly. And then I'm going to use this to narrow it down. All right, so if sine is less than 0, that means that this is negative. So sine is positive in the first quadrant, so it can't be that. Sine is positive in the second quadrant, so it can't be that quadrant. Our next clue tells us that cos has to be greater than 0. That means cos is positive. Cos is positive in quadrant 4. It is not positive in quadrant 3. So that means using those two clues, our answer must be in quadrant 4. Okay, let's try another example. All right, for the second example, we have cos of theta is greater than 0, and cotangent of theta is greater than 0. So again, I'm going to draw those four quadrants. All students talk constantly. So if cos theta is greater than 0, that means that we're looking in quadrants where cos is positive. So cos is positive in quadrant 4. Cos is positive in quadrant 1. So automatically 2 and 3 are out. Next, we're looking where cotangent is greater than 0. So that's where cotangent is positive. And cotangent is only going to be positive in quadrant 1. It is not positive where cosecant and secant are. So that means that this angle must be in quadrant 1. Okay, so next we're going to go ahead and look at, here's another problem. We're going to say find all trig ratios if sine theta equals 1/3 and cos theta is less than 0. So first, I'm going to have to figure out what quadrant I'm working in. Then, to find all the trig ratios, that means I have to know what sine is, what cosine is, what tan is. I'm going to have to draw a triangle to do all of that. So sine is positive. All students talk constantly. So sine is positive because it's a positive 1/3 in the first quadrant and in the second quadrant. That's where sine is positive. So it can't be quadrant 3, it can't be quadrant 4. Cos is less than 0. Cos is negative. So that means we can't be working in the first quadrant. So we must be doing something in quadrant 2. Now I can go ahead and draw a picture. I don't know why I'm drawing it so big. So it only needs to have space in quadrant 2. So I'm drawing a triangle in quadrant 2. The angle is always going to be the part of the triangle that is closest to the origin. You always draw the triangle so that you're going diagonally out from the center and then towards the x-axis. So if we were drawing a triangle over here, it would look like that, and this would be your theta. If we were doing quadrant 4, it would look like this. This would be your theta. If we were doing it in quadrant 3, it would look like this. That would be your theta. Okay. All right, so we have sine is 1/3, so that's opposite over hypotenuse. A little side note is if you were to be given a fraction that was positive or negative, you're just thinking about what you're doing. Are you going left and up? Then this number left would be a negative side to that triangle. This number up would be a positive side. The hypotenuse is always positive. Okay, so I'm going to write that in my notes. It might not mean a lot to you right now because we just talked about it, but it's important to know. So I'm going to say the hypotenuse is always positive. Hypotenuse is always positive. Okay, so now I'm going to go ahead and solve this right triangle. So I have 1 squared plus x squared equals 3 squared. So 1 plus x squared equals 9. That means x squared equals 8. And so that means the third side of the triangle is going to be the square root of 8. I can simplify square root of 8. I can say that is the square root of 4 times the square root of 2, which is 2 square roots of 2. So this third side is 2 square roots of 2. I'm noticing that in this triangle, I went to the left and I went up. Left means this 2 root 2 should be negative. This negative 2 root 2 is the whole point to you figuring out what quadrant your picture is in and drawing it out. The point of this picture is so that you can figure out which sides of the triangle need to be negative. If you are always going to draw all of the sides positive, you don't even need to put it in a quadrant. Okay? So the whole point of this picture is to make sure that that side is negative. So now I'm going to go through and I'm going to write all my trig functions. So sine theta, cos theta, tan theta, cosecant theta, secant theta, cotangent theta. Yes, you need to put the theta every single time. So sine theta is opposite over hypotenuse, 1 over 3. We already knew that. Cosecant theta is going to be the flipped version of that, 3 over 1, which is just 3. Cos theta is adjacent over hypotenuse, so that is negative 2 square root 2 over 3. Secant theta is going to be the flipped version of that, so that's 3 over negative 2 square root 2. And I cannot leave that problem looking that way. So I'm going to go ahead and fix this off to the side. So 3 over negative 2 square root 2. I need to rationalize that. So I'm going to multiply that by root 2 on the top, root 2 on the bottom. 3 times root 2 is 3 square root 2. We have a 2 right here, so I'm going to hold on to that 2. Root 2 times root 2 is also 2. So we have 2 times 2 is 4. And this fraction was negative. All right, so that means that secant, if I simplify it, is actually negative 3 square root of 2 over 4. Okay, then tangent is opposite over adjacent. So opposite, that's 1 divided by negative 2 square root 2. And the flipped version of that is negative 2 square root 2 over 1. This, since it's over 1, I can go ahead and say that's just negative 2 square root 2. This one I do need to simplify. So 1 over negative 2 square root 2. I can multiply that by square root of 2 over square root of 2. And so that gives me 1 times the square root of 2 is just square root of 2. I've got this negative 2 right here. Root 2 times root 2 is just 2. So I have this 2 times 2 is 4, and that was a negative. So that simplifies to be negative square root of 2 over 4. So there are all of my trig ratios, right? Now, if you are confused by drawing the triangle in a quadrant, I am going to ask you to do it at first, but if you don't like it, then all you have to do is this first part where you figure out you're in quadrant 2, so we know that sine and cosecant are the only ones that are supposed to be positive. And then you can go back to your answers and just make sure that sine and cosecant are positive, and you could go back to the other ones and put negatives in front of all of them. So if the drawings confuse you, there is a way to figure it out, but I would like you to try the drawings first and see if we can work with those, and then if not, we'll go back and we'll just work on switching the signs.